Well, good afternoon, everybody. Um, Today we're going to look at another one of the presentations that we covered at the 2016 user group. Again, this is in the same vein as the one that I showed last week with the print block, which is the idea of creating tools using the software. I'm just going to put on the webcam here, so bear with me 1 second and I'll show you exactly the part we're going to be making, and then we'll come back to the PowerPoint presentation and we'll talk through some of the basics around this example before we go into the software. So again, good afternoon, or good afternoon as it is in the UK here. So the example we're going to look at today is a mould created out of plywood, which is going to allow us to mould this part you can see here. This is a dragon's claw, white plastic, and it's got a bolt embedded here in the top. Hopefully you can see that there, that we can put a nut onto. It's threaded, and as I say, that's embedded in the mould, and this is moulded from two-piece plywood mould that looks like the part you can see here that I'm holding up, and this just goes together, and we put some melted material into this, which I'll talk about in a moment, and that allows us to form the claw with the bolt in it. And then ultimately, if you really want to, you could create something like this novelty coat rack with it, and you can see the one that's missing there is the one that I had out that came out of the mould. So I think that's enough of looking at me, so we'll go into the PowerPoint here, and what we're going to talk about first is just generally a little bit about mould making with a CNC machine. So what are the benefits of making tools using a CNC? Well, first of all, it's a particularly good application for a CNC because it does require accuracy and repeatability, and also the ability to create things like an inside and an outside shape. So things like the tools within the software, for instance, to offset a model or offset vectors, are particularly useful to us if we're trying to create something like this. Secondly, if we do produce a tool like a mould or a press or a die or a print block or any of the other things that we showed at the user group, then the cost or time to produce that tool can then be amortized over however many parts you produce with it. In this case, each of the claws that we make is maybe only going to take about 3 minutes, maybe 4 minutes each to make once we've created the mould, and the mould itself probably only took about an hour to cut. The other thing is that the software and a CNC allows you to create shapes and work with materials in ways that would be very difficult to cut directly on the CNC. So here you've got another example we're going to look at later in the week, and this is a mould to create bowls, and these are pressed out of a blank of Corian, and I've pre-cut some designs into these that are then pressed into those bowl shapes. It would be almost impossible for us to cut this shape exactly as it is here straight from the CNC, apart from the fact it would be incredibly time consuming. So there's actually some benefits to creating a tool with the CNC in order to do things that with the material we may not be able to do ordinarily. So some of the technical considerations to think about. We have to think about part release, so undercuts, the corner radii, smoothness and pinch points. You'll see in the example I'm going to show you today that we look at making sure the model is nice and smooth to avoid those types of things. Obviously within Aspire and on a 3-axis CNC machine it's not possible to produce undercuts, so we kind of automatically avoid that. Again, in today's example, you're going to see me look at adding draft angles, and that's where you've basically got an angled wall on the part in order to allow it to release. And I see somebody's put in a chat comment there asking if the video will be posted after we're done, and it certainly will be. It should be available within half an hour of us finishing. What I will probably do with the chat comments is maybe try and save those to the end unless they're particularly pertinent to the demonstration. So something else to think about with technical considerations is making sure the material can get into all parts of the tool. So depending what you're forming, whether it's something like a heated blank or whether it's liquid material, you've got to make sure that you allow for material thickness. We might need to allow access points, or as we're going to do in our example today, channels that will allow material to release from the mould. Have to think about the forming force and also the limits of our material, how fast and how much can it flow, what are its bend radius limits and things like that. Also, we have to think about position and alignment. In this case, we're going to think about the material placement in the tool, and in particular where we've got the bolt that we want to embed, but also making sure the two sides of our tool align with each other when we put them together. So our particular example today we're going to look at, as I showed you with the webcam, is a two-sided mold to create a dragon's claw coat hook. We're going to use plywood for the mold. I just wanted to create something that's cheap and easy to source. I wanted this to not really use any specialist material, or certainly not use material that's not easy for people to get. As I say, we're going to have this embedded bolt, and the material will wrap around that. And when you're finished, you end up with something like the part you can see on the screen here with the bolt there, and there's quite a bit of flash around the outside, and that just needs to be removed with a knife. I'm going to talk more about this in a moment. The material I use is something called thermomorph, and this is freely available off the web. You can order it from Amazon in a tub. I think there's got about 18 ounces of material in it. Some of the technical considerations I mentioned before: the alignment, so the mold halves and the bolt. The mold release, we're going to use the draft angle and smooth the model, and also the material access channels, which is where the material squeezed out the top of the mold here. So in terms of what we did with the actual process for this, when I produced the mold itself, there's a pot of this thermomorph material. This is actually small white pellets, plastic pellets. In order to make this formable, we pour hot water onto it. So basically you have to boil some water. If you just excuse me, I'm just going to take a drink. Sorry about that short pause there. So we pour hot water on here, and then that becomes a kind of clear or malleable substance, almost a bit like something sort of like Play-Doh. Maybe a kind of a clay. It's very odd kind of form that it's in once you've got the hot water on it. Obviously it's hot, so I'm handling it here with a spoon. I then press that into the mold. I've approximately measured the amount I needed before. You can see that's clear in there, showing that it's still formable. Formed it around the bolt, which is held in place, and then I put the other half of the mold on it and literally stood on it in order to create the pressing force. Now you could use something like a press, a proper press for this, or maybe a vise or something like that, but as I say, I was trying to work with really basic tools here. So there's my feet just standing on top of the mold. Once we open the mold, we can see something like we've got here. Now I found after I've made one of these that if I wanted to open the mold before the material sort of cured and became its white colour, then it helped to put petroleum jelly onto it for releasing the part. So I'll just smear the petroleum jelly around the mold here, and that would just help me to be able to prise that apart more quickly rather than having to wait until the material had cured. There you can see what the part looks like when it's cooled down completely, and we remove the flash from it, and then, as I say, you maybe have an application like I've got here. Now, as with a lot of the demonstrations we show you with Vectric software, don't get too hung up on the fact of the particular subject matter of this being this dragon's claw. I understand that the vast majority of people will never have any interest in making a dragon's claw. The key part of this demonstration though is going to be showing you the process for creating a mold from a 3D object. So that's really the key here. Now the first part of our demo is going to be to create our model. So I am just going to do a quick modelling example in Aspire to create our dragon's claw model. At that point in time, if you were interested in modelling something else, you would just substitute the dragon's claw model for the model of whatever you want to create. So something you'd modelled in Aspire, or something maybe you brought in from another 3D modelling package. So the second part of the demo will be to take our model and then to prepare it for making into a mould. So to do that, we're going to add draft to allow the part to be released. I'm going to create, in this case, my bolt location channel and also the channels for the excess material to escape, and then we're going to invert the shape. I want this to be a negative shape that I can put material into. Now I prefer to model with everything as a positive, so I'm only going to do that just before we get to the stage where we create the toolpaths. Finally, we will duplicate to make the other side, and we'll create a simple set of toolpaths to cut this, including the dowel holes that are going to give us our alignment when we put the two halves of the mold together. So this is the part we're aiming for here. So as I say, this is 2 halves of the mould. We're going to cut this into plywood. On one side we've got a place to put the 3 dowels, and then on the other side we'll have 3 mirrored holes there that will basically align with those when we want to push the 2 parts together to form our part. So that's the introduction done. Let's go into Aspire, and for this we're going to use Vectric's 8.5 version of Aspire, so the current release of the software. I'm going to start by opening a file, and I'm going to open a file in order to create our dragon's claw that's got some pre-drawn vectors in it. Now these are a very simple set of vectors that we've got here. If I just switch off those vectors and we select the bitmap layer, you can see there is just a simple sketch that I made here of what I wanted my dragon's claw to look like. I've imported that into Aspire, and then I've just drawn a simple set of vectors over that. Now I'm just going to undraw the bitmap layer there, and we'll work on the vector layer here. Now so we can see what's happening, I'm going to tile the 2 windows, and I do that by hitting the page up key on the keyboard, which is the shortcut to tile the 2D window on the left and the 3D window on the right. Now we're going to use a simple 2-rail sweep in order to form this shape, but we're going to really need to get control of that shape in order to make it look exactly the way we want. So if we go onto the modeling tab, I'm going to go into the 2-rail sweep function, and I'm going to select my 2 drive rails. I'm going to select the bottom one, then hold shift and select the top one here and click on the button to use selection, and then I'm going to click to select my cross section. Now at this stage I'm just going to uncheck this scale cross sections with width and take the values we've got in here and call this claw and hit apply. Now you can see by unchecking the scale cross section with width, I've just got a flat shape being created. That is the same height all the way across. Because I'm creating quite an organic form in this case, I definitely do want to scale that, so I am going to make sure that option is checked on, and then I'm going to hit apply again. Now my shape looks more interesting now and is varying in height, but I can see it still doesn't look as I would want it to for my dragon's claw. It's twisting around, and the reason for that is where the software is automatically placing the cross section as it flows along these 2 drive rails. If I want to see those positions, I can click at the start here and the software will actually show me those as lines. These can be a little bit tricky to see maybe in the display, but hopefully you can see them across there. What I want to do to control this shape is input my own positions for these cross sections. To do that, I must have it selected as it is here, and then I'm just going to click in the 2D view and just drag the ends where I want them to be. So I'm clicking on the bottom drive rail to position the first point, and then dragging on the top drive rail to position the second. And I'm just going to go around and put those in the position where I'd like to see creases in my shape. So in order to do this, I really just thought about how a finger is formed, and so we're just putting that across these key points in order to then be able to come back into the form in a moment. So that's the last one there. Hit apply again, and now you can see the shape updates, and I've got something much closer to what I'm looking for. What I'll be able to do now is once I've created the pads on this, come back in and we're going to finish this off with the sculpting. I'm really not looking to create a perfect model. I'm going to do a lot of tidying up with the sculpting tools. So I like the way the claw looks. I'm going to hit close now, and the next thing I want to do is model these pads, but I want to sort of create them as if they were sort of recessed into our design here. To do that, I'm going to create a platform slightly lower than this claw that they can sit on. So I'm going to base that on the original claw model. I'm going to right mouse click and duplicate this model here. I'm going to undraw the original, and with the new one selected, I'm going to go into the properties with the wrench icon, and I'm just going to reduce the height of this down to 1/4 of an inch and hit the space bar to apply that. So now I've got a slightly reduced height version of the claw, and what I'm going to do is select these vectors here, and again I've just very roughly drawn these, and I'm going to create a shape from those vectors. I'm going to create a rounded shape with a 90-degree profile to create nice sharp edges, and then I'm just going to limit those so that they don't go above 0.1 of an inch. In this case I'm going to scale them to that height so I still get the full roundness rather than a flat on the top. we'll just call this shape pads and hit apply and close, and we can see that's being added to that shape, so it's just following the form there. Now that is where I want those pieces to be, but I now need to be able to blend those back into the original claw, and for that I don't want the rest of the model here, so I'm going to select the lowered claw that we made, shift and select those pads, and just use the icon here to clear the area outside of that second selected shape. So now what I'm looking at in the 3D view is a component that represents our lowered claw with just that area cropped out with the pad sitting on top of it. And we're going to come back to those in a moment. I'm going to switch back on the higher claw here, and what I want to do is just make it so that I can only see in these portions where the lowered claw is, and to do that we use an unusual combine mode, or one that doesn't get used very often. There you can see these are being set to add, which is not what I want. I'm going to right mouse click and change the combine mode to low, and what that will do is take those two overlapping shapes and just keep the lowest out of each one. So you can see that now I've got that kind of lowered platform, and when I switch those pads on again, they're being added onto there. Now, as I mentioned before, I've deliberately modelled this in a pretty haphazard way. I haven't worried about really making it clean or detailed, and the reason for that is I knew I was going to come back to it towards the end of the process here and really smooth this heavily, because I don't want any very sharp corners, and also use the sculpting tools on it to finish it off. So let's just look down the Z-axis for this for a moment. In fact, I'm going to maximize the 3D view so we're focused on that there. And what I want to do is create a safe copy of this. So I'm going to right mouse click and insert a new level, and I'm going to take the visible model and just use the icon here to create a component from the visible model. So that creates a copy, and now I can undraw level 1 and we can see the shape there. Now that is a completely new copy of our objects, so I could go back to these originals and edit them anytime that I wanted. So I can edit this without fear of losing that data. Now zoomed in on that, I'm going to come up and I'm going to click on the icon with it selected to apply the smoothing filter to this. Now, as I mentioned before, when I'm creating a mold, I really want to try and avoid having too sharp corners. Plus, because of the way I've modelled this, I really need to get rid of some of the messy overlapping areas. So I'm going to go to maximum smoothing with the slider bar and click on the button to bake current smoothing. I'm then going to push that all the way to the max again there and bake the current smoothing, and in this case I'm even going to go a stage further and do that, and we'll push that once more to the max and bake and hit OK. And we'll close that then. Now I like the way that looks. I've got rid of anything that's too sharp that the material really wouldn't be able to properly get into, and now I just need to tidy up some of these creases that are in areas maybe where I don't want them to be. Now of course this is a dragon's claw, so it doesn't need to look perfect. Nobody even really knows what a dragon's claw looks like, or so we presume, and so we should be able to just tidy these up and make it look exactly as we want. If I liked, I could even sculpt some scales into it, or really do anything I wanted to finish off the model. So let's select our model, go into the sculpting tools, and to start with I'm going to go to the smudge, and I'm just going to go with a diameter about halfway along the slider bar here, and strength around about halfway as well, and I'm just going to come back and forward over this crease, and you see using the sculpting tools in Aspire it's nice and easy for me to just kind of blend those areas together. I can just adjust the different values here if I want to change anything, if we want to pull that pad out a little. Also, if I want to reduce the diameter, I might want to cut these pads in a little bit more here. So it's really up to me how and where I do this smoothing. Now in this case I'm using a mouse, which does make this a little bit more tricky to do. If you are going to do a lot of smoothing, or sculpting rather, with the program, then we'd really recommend getting something like a Wacom tablet to help you, because that'll give you better control over it. But as you can see, it is possible to come in with the mouse and make changes here, although definitely takes a little bit of practice. As well as cleaning up these creases, I could also come in and make changes to the design. Maybe we would want to come in and actually add some parts up the top here. We could come in and put those in there. And as I say, if we wanted to, we could even come in and start adding scales in here. So we could say remove, maybe increase the size, and I could just click and work my way around like that. So I could sculpt this for as long as I wanted. For my actual part that I moulded, I maybe sculpt it for about 10 minutes. And what I'm going to do is just cancel the sculpting on this one and go ahead and switch off that. And I'm going to import the finished version that I created that's saved here as a 3D clip file. So this is the one that I actually molded, and you can see I added in a little bit of rough detail around here up the top here. There's nothing very clean about this model. I really intended it to try and look sort of semi-realistic. You know, if it was too perfect, then it wouldn't look like an actual organic item. Now, as I mentioned in the introduction, there's kind of two stages to what I'm showing you today. This first stage has been just showing you the process to model a dragon's claw. So hopefully you've picked up a few tips and tricks from that about the two-rail sweep and positioning, things like the cross sections, even the fact that we can create quite a rough model and then maybe go in and finish it off with the sculpting. Now, in terms of creating a mold from this, that's what we're going to get into next. So assuming that you don't want to make a dragon's claw at this stage, what you do is just substitute the dragon's claw for a 3D model, something that you created yourself in Aspire or something you'd created in another modeling program. And then you would go through the set of steps that I'm going to show you in a moment in a new session of the software. So I'm going to close this now. We have that model saved. I'm going to create a new file which is large enough for me to create the two halves of our plywood mold, and I'm going to work in inches here and make this 8 inches by 8 inches, and the plywood I'm going to use is going to be 3/4 of an inch thick, and we're going to set the datum in the lower left hand corner, and we'll work with a modeling resolution of very high just to get a reasonable detail with this part. So I'm going to hit OK, and we've created our model there. I'm going to tile the two windows again so we can see the 2D and the 3D view. The first thing I want to do is import our 3D model. So as I say, basically this 3D object could be anything you want. In this case it's the dragon's claw. Somebody's just posted a comment there on the chat that says, will the source files be available? They won't be available immediately after this. What we're going to be doing is broadcasting all of the videos from the user group over the next few weeks, and then eventually we will add them to the website and all the source files will be available subsequent to that. So eventually the answer to that is yes, but they won't be immediately available after this video has been recorded. So as I say, if we get back into here, we're going to import the 3D model. So imagine this is any 3D model you want to create as a mold, in this case, or something you've already drawn in Aspire. There's our dragon's claw. I'm going to hit F9 on the keyboard to center that in the middle of the job. And now we need to think about some of the things we talked about in the introduction. And one of those is this idea that what we want to do is try and avoid vertical walls and certainly avoid undercuts on a mold in order to help the part release. Now you can see at the bottom of our claw we do have a bit of a vertical edge here, and so what we'd want to do is add what is typically referred to as a draft angle on here, so that there is actually a minimum angle on all the vertical edges of the part, and that'll just help it to come out of the mold. Now there's a tool in Aspire that allows us to do this. I'm going to zoom right in here so we can see the effect of this, and this tool is this icon here, Add Draft to Model. And what that does is it takes the visible model, so any visible components you've got, and it allows us to enter an angle. In this case I'm going to put in quite a high angle of 20 degrees so that we can really see the effect it has, and I'm going to hit apply, and the software will take the visible model and then create a new single component from that with the draft angle applied to it. In this case we only have a single component, so we're just going to be left with two components after this, the original sculpted claw and this model with 20-degree draft that you can see added to the component tree. If I switch that off, the new model, you can see in the 3D view how that draft angle is making a difference. I'm just toggling the new model on and off, and there you can see hopefully that diagonal angle that's been added to the edge of the part. So that will just help us to release any 3D molded object, particularly when you've got something that may be heating, cooling and contracting or expanding. So I'm going to switch off my original claw. We're going to work with this new model with the draft added to it. Now in this example what I need to start thinking about is the overall size of my mold, so I need to draw some vectors for that. And then also I want to put in a channel that we're going to be able to mount the bolt into for this example, as well as the channels that will let material escape when we press the two halves of the mold together. Now, as I mentioned before, I prefer to model everything so that it's positive. So I'm going to work with this model as a positive shape, and then the last thing I'm going to do before we go over and start calculating the toolpaths is invert this so that we've got the cavities rather than the positive. I just prefer to work with positives because I find it easier to merge and add positive shapes rather than trying to do it with negative shapes. And as you'll see, it's very easy for me to just invert this at the end anyway, particularly using the levels. So I want to draw some vectors. First, I'm going to come to the Drawing tab. I'm going to create a rectangle, and for the outside of our mold we're going to make the part 6 by 3 1/8, and we'll just put that at x0, y0 and hit create, close, select that and hit F9 to center it. So that looks like it's reasonable size. The part will be sat in the middle there. Next, I want to create the bolt location, but also I need to think about the fact that when we make a hook out of this with the bolt in it, I need a flat edge for that hook to mount on my coat rack. So I'm actually going to have to trim off the end of the model. So I'm going to create another rectangle and just sketch that over the end here. I'm going to select the model, shift and select the rectangle from the modeling tab. I'm just going to click to clear the area inside that selected vector. So that's just going to crop that part of the model off. I'm going to delete that rectangle now, and we can see in the 3D view we will have a flat edge that we can push against the coat rack. Now you may be thinking that that flat edge doesn't have the draft angle on it, and that is correct. In this case I think this material is going to be malleable enough, and that is a small enough vertical edge that it won't hold our part in place when we're trying to release the mold, and that actually was the case when we created this. So sometimes you just have to make those decisions. Certainly I don't want a draft angle on this, otherwise I'd have to clean that off afterwards in order to create the flat edge that's going to mount on our board to make the coat hook. Now we're ready to create the bolt location. Back to the Drawing tab. I used M5 bolts, and so I decided I wanted to create a little cylinder or half cylinder that was 6 mm across in order for that to sit in. So I'm just going to sketch a rectangle here, and I want the width of that to be 1 1/8, which was the length of the bolt, and I say the height here I want to make 6 mm. Now I'm working in inches, but I can use the calculation function within Aspire to help me to convert that. So I could put 6 for my millimeter, put the asterisk, which is the multiply, and hit I for inches, and then when I hit equals, that'll show me the inch equivalent of 6 mm. So to do that, 6 asterisk and then I to convert it to inches, hitting the equal sign in order to get the number there, and now I can hit apply, and that's sized as I want it to be. Now I'm going to zoom in. I'm just going to eyeball that position. Imagine that the head of the bolt is going to be at this end, trapped inside my plastic, and then this is just going to create a channel for the bolt to sit in when we're forming it. So I want that channel to be a half cylinder, so let's do a 2-rail sweep. I'm going to open up this by going into node editing mode by hitting N on the keyboard, hitting D on the keyboard to delete the 2 spans at the end. Now I'm going to click Draw Circle. I'm going to snap to this endpoint and snap to this endpoint. Right mouse click to accept that. Hit N on the keyboard to go back into node editing. And what we want this to be is basically half the size, but I'm going to remove the 2 bottom halves there, but this is still too wide. I actually need it to be half the size, not just half the circle. So we can take that and we can size the object, and I can just put in here divided by 2 equals link XY is checked, and so that'll just scale that down for me. Now if we drag that out the way, come onto the modeling tab, I'm going to select my 2 drive rails, go into the 2-rail sweep, so use selection. I can see that they're going in different directions, so for the top one I'm going to right mouse click and reverse that rail. Next I'm going to select my cross section, I'm going to uncheck scale cross section with width. I'm going to set this to merge, and we'll call this bolt channel, and hit apply and close. And there you can see that little cavity, when this is inverted, that the bolt's going to sit in has been created for us in the 3D view. Now, in order to create the two channels at the top that are going to allow material to escape from the design, I'm going to use the vectors and that model and just make copies of it. So I'm going to delete this cross section. I'm going to select both the vectors and the model by box selecting around it, click on it again to go into transform mode, and then hold down Control and Shift in order to drag that up and make a copy of it. The Control makes a copy, Shift just drags it up vertically. On the keyboard, I'm going to use a shortcut to rotate the model 45 degrees. I'm going to hit 9 on the keyboard and then 9 again, and that'll rotate that 90 degrees. Now I'm just going to move that into position there, and again holding Shift and Control this time, I'm going to drag that across here. Now what I want to do is just reduce the size of this down in order to make a thin channel that's just going to merge into the end of the claw there. And then if we just scroll across here, I'm going to take this shape and both the vectors again, and we'll just increase the size of that and put that in place to make a larger channel. So we can see those merging in, and they're just going to allow the material to escape out the top of the mold. Now at this stage, I would like to create a boundary around the outside of this that we're going to use for machining, and also think about making this a negative shape now so that we've got our cavity that we're going to need for our mold. So let's work on the boundary first. To do that, I want to create a boundary that not only includes the claw but also these channels as well. Now I don't want that to go too far past the edge of the top of the model, so I'm going to create a line on the drawing tab just snapping across the top there, and with that still selected, I'm going to move that relative to its current position up 1/8 of an inch along the y-axis. Now let's just maximize the 2D view and zoom to fit and zoom in here so we get a clear view of this. I'm going to go to the interactive vector trim and just click in order to snip off the areas that are sticking out above that line and to the sides of it. So now we've got these two vectors here. Next, I want to create a vector around the outside of this 3D model. We can do that on the modeling tab using the icon here to create vector boundary from selected components. So I'll make sure that model is selected, click on the icon there, and that instantly creates a vector around the outside. If we come back to the drawing tab, what I want to do is just weld together the boundaries around the channels and that new shape. So I need to make 4 closed shapes. So with these two vectors selected, I'm going to click on the icon to join with a line. We'll do that twice. Do the same with this one and the same with this one. So now I've got 1, 2, 3 rectangles for my channels, and then 1 vector around the outside here. And if we come over and click on the icon to weld the selected vectors, now we can see we've got a single vector around those. Let's just hit F on the keyboard to fit that into the job here. Next, we'll hit page up, so we've got the 2D and the 3D view. Again, I mentioned before, I like to model with the objects being positive, but at this stage I've created all the 3D shapes I need, and we're ready to actually go ahead and invert this so that we can create our mold cavity. Now, if you're ever creating a negative shape in Aspire or even in VCarve, you always need to make sure that you have a reference 0 plane to just ensure that the software knows to create the toolpath all the way up to the top edge of the part. So just a very simple rule, just think if I'm ever creating a negative shape like a dish or a mold cavity as I am here, I need to have a reference plane that's a component. To create that component, I'm going to go to the model drop down, click on the icon here or the option in the menu to add 0 plane, and that'll create a new component here in my component tree called 0 plane that you can see in the 3D view and in the 2D view there. Very, very important to do that, even if you don't exactly understand why that's necessary. When you're creating negative shapes, that is extremely important. Now what I want to do is take away everything that I'd created before from that 0 plane to create my negative cavity. Now in order to do that, the easiest way is for me to put those onto different levels so that I can just subtract the result of the level with all the channels and the model on it from the 0 plane. So let's right mouse click on level 1 and say insert new level. I'm just going to select the 0 plane, move it onto that level, and then we'll just drag that down so that it's below level 1. And on level 1 I'm going to right mouse click and change the combine mode to subtract. So what that will do is take the result of all the visible components on level 1, but it will then subtract it from my 0 plane, and that gives us our negative shape that hopefully you can see in the 3D view there of our part. And this is the part we're going to machine to create our mold cavity. Now the last thing I need to do before I create the toolpaths is to make a duplicate copy for the other side of our mold cavity. So I'm going to select all the vectors and the components there, going to move the selected objects, and we'll move those to an absolute position where the lower left corner is 0.5 of an inch above the Y0 position. Now to create the other side of this I need to mirror it, and just before I do that I want to think about my alignment method between my two halves, and to do that in this case I'm going to use 3 dowels. So I've already measured my dowels. I need to create holes that are 0.32 of an inch across, so I'm going to type in 0.32 in the circle tool, and I'm just going to click 3 random positions in there in order to create those circles. Now I can take all these vectors and we can mirror those about the center of the part. I could do that with the shortcut Control Shift V, or we can do it from the menu here. If I say flip about job center and create a mirrored copy, I'm just going to click on the button to flip vertical, and now you can see we've got the 2 halves of our mold ready to be machined, and we've got a mirrored set of vectors to help us do that. So with the part in this stage, I'm going to click on the icon to switch to Toolpaths tab, and for the 3D machining I'm going to use a large ball nose in order to rough this out with a raster strategy, and really this is more akin to what you'd typically think of as semi-finishing rather than a roughing toolpath. So I do want to select these 2 vectors as my boundaries. I'm going to check my material setup here. I've got 3/4 inch material, XY datum in the lower left corner, that's both good. Because of the nature of this model, needs to be right up against the surface of our plywood. So I need to make sure the gap above is set to 0. It is in this case. You might find your model is in a position like this, in which case you just use the slider to push that up, or you'd enter the gap above to be 0 there. Need to check the rest of my parameters are safe and appropriate for my tooling and machines, and then we can hit OK. Now with these vectors selected, we can click on the icon for 3D roughing, and to do this I'm going to use a 1/4 inch ball nose tool. Not going to worry about the speeds and feeds and things for this. We'll just take that as being appropriate and hit OK. And I'm going to say I'm going to use selected vector, boundary offset of 0, machining allowance 0.03 of an inch, and I'm going to use the 3D raster in order to cut this. So we'll just edit the name and hit calculate, and we'll see what sort of toolpath that gives us. Should be familiar with the way that the Z-level roughing or the Z-level roughing works. This is similar, but it's going to follow more closely the 3D shape of the part, so that if we preview that we can see that it's probably going to do a bit better job of clearing out the material from there. Now we can come in with a nice small tapered ball nose using the same boundaries, and we can do the finish machining. So here's, if we select here, we've got a tapered ball nose in the list. So we're going to use this. This has got a nice small tip radius on there, so the total tip diameter is 1/16 of an inch. Again, just make sure the feeds and speeds are appropriate. We're going to use selected vectors, boundary offset of 0, and we can hit calculate, and then we can preview that to make sure that that's going to give us the detail that we're looking for in the mold. Now I can see from the preview that I've used an offset pattern. I think in this case it would probably be a little bit better to use a raster pattern, so we start at the top edge and kind of work our way down and through. So I might change that, having seen it. It may not really make too much of a difference because we've removed the majority of the material already, but anytime you see something in the preview you do want to change, you should alter it. Now I can re-preview the roughing and the finishing, so we can just double check that that looks okay. And then for the last stage we're going to calculate the toolpaths for the dowels and then our cutout toolpaths to finish the part off. So that looks good. For the dowels, on the bottom part of the mould, or on one half of the mould, I want the dowels to be a nice tight fit and not all the way through the mould. So I'm going to select these three, go for a profile toolpath, not all the way through the material, using a 1/4 inch end mill inside, and I'm just going to spiral those out. So we'll call those profile dowels 1/2 inch there, just something to indicate they're not going all the way through, and preview that. And then I'm going to duplicate that. I'm going to double click on it. We'll change this and call this through, and I'm going to select these dowels. Now these need to go all the way through to allow this half of the mould to be put on and off the dowels that will be inserted in the lower section here. So I'm going to cut all the way through. Z plus 0.01 equals, so just a little bit through into my spoil board inside, and also I want a bit of an allowance because I don't want these to be a tight fit, so I'm going to put a negative allowance of 0.02 of an inch on there. Hit calculate. Software warns me it'll cut through. That's okay, I want it to. Can see those machined through there, and if I wanted to check that allowance, I could make that visible, use a solid preview and zoom in here to see they're being overcut. So now I know that they'll slide nicely over those dowels, but they'll still work in order to align the two halves of the mould so that they're a close enough fit. Now to finish, we're going to cut the part out. So I'm going to select these two rectangles. I'm going to cut this out, cut slightly through into my spoil board outside. I'm going to add tabs. So we just make these something that's appropriate for the material. Click on Edit Tabs, and I'm just going to pop 3 tabs onto each half of the mould. And we'll say Profile, Cutout, hit Calculate, and then we can preview that, and we should see in there that that is going to give us what we were looking for. If we maximise that, we've got the two halves of our mould there. So that almost concludes this particular presentation. I think, as I said, one of the main things from this is to really be able to sort of differentiate the two halves of the demonstration. The first half within the software was just creating this dragon's claw. That's just purely a modeling demo to show you some of the tools that are available in the software. The second half, where we took that claw, we added the draft angle, then we did the other preparation we needed to do in order to create this into a two-sided mold with the cavities in each side. Really could be done on any 3D model that you bring into the software. I should just note for anybody watching this that isn't aware that the clip art that comes with the software, or from Vector Art 3D or Design and Make, is not licensed to be used to make molds with. So this has to be something that you've modeled yourself. You shouldn't be making molds with the clip art unless it's for a very limited use, personal use. So that concludes this demonstration. As I mentioned, this will be available probably within half an hour or so. Really, that just depends how long YouTube take to process it and add it to our channel. So if you have missed it, as somebody's just commented on there, then you should be able to see this in the not too distant future. And as I also mentioned, we'll be scheduling other demonstrations over the coming weeks. I have another one tomorrow, again at 4 o'clock PM UK time, which I believe to be 11 AM Eastern in the US as a reference. So I have another one tomorrow on Tuesday, another one on Wednesday, which I believe will be the 26th of October, but they'll also be available subsequently as well. Then we'll be scheduling some of the other demonstrations from the user group, and eventually all these will be made available on the website, including the files as well. So that concludes this particular example. I can stay online for a couple of minutes if anybody wants to post any questions on the chat. So I will give it a second here for anybody to do that if they want. I'm glad that was very helpful. I think we've got a bit of latency in me seeing the chat and me actually finishing talking here, so there may be a couple of gaps here. So there's a question there, can you invite us to the other sessions? We don't invite you because this is basically a stream over YouTube. It's just a case of coming to our YouTube channel at the time. If you go to the Vectric forum, then you will see the links there so that you can access these. So if you go to the Vectric forum and look, there's a title there, you will be able to see it. Just again there, for anybody that has missed this, it will be available within about half an hour or so. So there's another question there about going over the calculator with millimeters versus inches again. So if I just go over to the drawing tab, in order to convert something from metric to inches, so first of all I'm working in inches here, so I would like the values ultimately to be in inches. So let's say we had a 10 millimeter circle we wanted to draw. I might come into the circle tool like this. I'm going to put the metric value that I want to convert. I'm going to put an asterisk, which is effectively on a computer the equivalent of multiply, and then I'm going to put I for inches, and then I'm going to hit the equals key, and the equals key is what's going to convert that into a numerical value. So 10 millimeters converted into inches is 0.3937. If you're working in metric and you wanted to go the other way, then what you would do is you would type the inch value and then the multiply, the asterisk again, and then you would type M in order to convert that to metric, and again hitting the equals. So I say, just to reiterate that, put the metric value in if I'm working in inches, multiply I to say I want to convert it to inches, and then hit equals on the keyboard in order to do the calculation there. So at this stage I'm going to stop the recording here. I think hopefully we've answered everybody's question. If there are others, please feel free to go on the forum and post them, and we'll do our best to answer those there. And thank you very much for your attention and watching today's demonstration.